Notes from yesterday, you can. Yeah? Okay. Which makes them what? Yeah, congruent. Yeah. There was two parts to this definition. They were the same blank and the same blank. Yeah? I think that's a good idea. Good job. So congruent figures are the same shape and they are the same size. Noelle, what you said is not wrong. They have the same side lengths and equal angle measures. That's what makes them the same shape and the same size, right? And then we talked specifically about the definition of congruent triangles. Your definition of congruent triangles, yes, they're going to be the same shape and the same size, but more specifically, what will we be looking for? They are going to have two things: 3 congruent pairs of sides and also 3 congruent pairs of angles. Now, this is super important. This is going to be what we are using, what you need to have in every single proof that we're doing today. Okay? Now, the good part is these proofs are long, but when we get to day 3, you're never going to write a proof this long anymore because we're going to use the shortcuts. And you're like, well, then why are we doing these? Because I want you to understand how these proofs work, like the logic behind them. And I want you to use this definition. Okay? So in your proof, before you say triangle ABC is congruent to triangle whatever, you need to somewhere say that you have 3 congruent pairs of sides and 3 congruent pairs of angles. Okay? You're going to be given information. You're going to be able to assume some things. Okay? But you can only assume certain things. We'll go over those. All right? Okay, so look, it's completely blank, and there's 10 steps, and that's probably extremely terrifying, right? Because you're like, where do I start? Where are we going? All right? What I need you to remember is this. We need to look for 3 congruent pairs of sides and 3 congruent pairs of angles, because this says write the proof using the definition of congruent triangles, okay? From after today, you're going to be able to use your shortcuts, all right? Look at all this given information. Before you write your proof, okay, stick with me on this. Before you write your proof, I want you to mark all of this given information, and let's talk about where our congruent angles and sides are in our triangles. Then we'll go write our proof. Are you with me? Yeah? Okay. So, I tell you, your first piece of given information is that angle YWX, so this angle right here, and angle YWZ, this angle right here, that they're both right angles. That's marked for you, right? But does that statement explicitly say this angle is congruent to that angle? No. And that's what you need, right? You need 3 congruent pairs of sides and 3 congruent pairs of angles. Okay, but what do you know about right angles? They are
90 degrees.
Okay, and if they're both 90 degrees, then they are? Yeah, but I don't want to go there. My goal is this. Then they're congruent, right? If they're both right angles, then they're congruent.
Would that be definition of right angle?
No. What is the definition of a right angle? I'm glad you brought that up. Is that telling me that those angles are congruent? No. So she just asked, is what we just used there the definition of a right angle? And I said no, because then I asked, what is the definition of a right angle? And you said that it equals 90 degrees. Equaling 90 degrees does not mean congruence, right? Yes, they are both equal to 90 degrees, so you know that they're congruent by those definitions, but there is something called the right angle congruence theorem that we talked about way long ago. And you're like, well, how do you expect me to remember that? I've kind of warned you, like, all these things are fair game for you to use in a proof, okay? These things will be coming back up and you will become more familiar with them and realize when to use them as we write more of these proofs. But that is the theorem that justifies why these angles are congruent, okay? All right, those of you that are writing, I haven't written anything in at least 2 minutes. Please stop and listen to me. Okay? Thank you. Okay, so there's one pair of congruent angles. We need 3. Let's keep going with our given information. I tell you that YW bisects angle XYZ. I guess I should also mark this one as a right angle. Sorry, I forgot that. The next piece of given information says that this segment bisects angle XYZ. What does the word bisects mean?
I guess splits it into 2 equal parts.
Okay, so listen to me. If a segment is bisecting an angle, am I going to mark congruent segments or congruent angles on this picture? Angles. Okay? Whatever follows the word bisects is what you're going to mark. Okay? So if a segment bisects an angle, that means that these 2 angles right here are also congruent. Why? Haven't used this one in a while either. What was the question that I asked you? I asked you, what does the word bisects mean? And you told me that it creates 2 congruent parts, right? So that right there is the definition, right? When you think, what does that mean? And you say it creates 2 congruent parts, there you go. That is the definition of an angle bisector. So look, we have 1 pair, 2 pair of angles, right? Move on to your next piece of given information. W is the midpoint of this segment. What does that help you mark? If W is the midpoint of this segment, does that help you mark a pair of congruent segments or angles? Segments, right? So if you're looking at this segment and W is the midpoint, that means this and this segment are congruent. And that's the information that's going to follow, because this right here straight up doesn't say this is congruent to that, right? But it helped you mark that pair of congruent sides. Any thoughts on the reason for that? If you know this, how come you knew this?
Definition of a segment.
Not a segment bisector.
Definition
Of a midpoint. Yeah, exactly. What does that mean? What does that help you mark? What does this information help you mark? 2 congruent segments. That's the definition. All right. I also tell you what XY and ZY are congruent. Whoops. Okay, that's just given. That's just straight up going to be given in our proof. No definitions or anything there. So what do we have right now? We have 2 pairs of congruent sides, 2 pairs of congruent angles. Am I good? Is that enough for me to say this triangle is congruent to that triangle? No, I'm missing some things. Hannah?
The reflexive property.
Good idea. The reflexive property, you're going to use that in your proof, okay? That's not given to you. That is one of the things that you can always assume. Reflexive property. Okay, you use that in the hinge theorem. So this is my 3rd pair of congruent sides by the reflexive property. What about angle X and angle Z? You have no more given information. Do you know?
Can't you assume that those 2 be congruent?
Yeah.
Because the other
Do you know what theorem that's called? You're right. You just explained that perfectly to me. But there's a name for it.
I don't
When I say it, you're going to be like, duh.
Is it congruent?
No. It's the third angles theorem. Because guess what? The way you explain it is the third pair of angles. If you have two pair of congruent angles, then the third pair of angles is always congruent. Okay? The third angles theorem. You're going to use that today, and you're never going to use it again in any of your other proofs. Okay? All right. So, look. You have all three pairs of sides marked congruent and all three pairs of angles. So, guess what? These triangles are congruent by definition. Now, how do you take that and put it into a proof? All right, stick with me. Because these are blank, when they are blank, you can have a different order than I do, right? The way you could do this is just straight up list all of your given information in the first, 1, 2, 3, 4 boxes. That's fine. But what I would recommend is, I told you this first given information doesn't say this is congruent to that, right? So what I would do is I would put that first piece of given information in box 1. It's given. But then what did that help you go mark on your picture? I would put that immediately after. Like, what information did you pull from that? Does that make sense? Okay. So that's what we're going to do. Angle YWX is congruent. Nope, sorry. And just straight up write it as you see it. And angle YWZ are right angles. That's given. But that doesn't say that this angle is congruent to that angle. But when we were marking it on our picture, we knew that these angles were congruent. Do you remember the reason? Anybody remember the reason what I said? If they're right angles, they're congruent. It's called the right angle congruence theorem. So here's what I like to do when we're writing these proofs, because it's a lot. When you get a congruent pair of angles, you kind of have a checklist, right? I need 3 congruent pairs of sides and 3 congruent pairs of angles. There's 1. So why don't you, like, in another color, put like a check mark next to it and be like, okay, this is one of my congruent pairs of angles. You need 3 pairs of congruent angles somewhere in your proof and 3 pairs of congruent sides somewhere in your proof before you finish. Okay, there's 1 pair of angles. Also, you may want to go up here and cross out that given information because it's done. Don't use it again. Go back to your given information and use another piece. Segment YW bisects angle XYZ. Now, we already talked about this, but what did that help me mark on my picture? What did that information help me mark on my picture? Tessa? Right here. So if this segment bisects that angle, XYZ, this information came from this, right? W being the midpoint of that segment. Remember I said whatever follows the word bisects, which is an angle, is what it's going to help you write. So you want to change your answer?
Yeah.
Not the segments,
Like X and Z,
the angles. Can I just say angle Y is congruent to angle Y? No, because there's more than one angle at Y. So you have to name it with 3 letters. So how would you name this one right here? Angle.
XYW.
That works. And then this one right here.
ZYW.
And why did you have to use, if you did XYW, X is corresponding with Z. Do you remember everything we talked about yesterday? Wherever you see X, you always got to see Z, right? So if you say X, Y, W, you got to say Z, Y, W. Are you with me? Yeah? Okay. Oh, this was given. Sorry, I forgot that reason. Anybody remember what that reason was for that pair of congruent angles? Do you remember? Mm-hmm. There's not a theorem with angle bisector. It's going to be a definition. Okay? And guess what? Put another pink check mark or whatever you used. That's your second angle. Right? Don't put a check mark next to this at step 3 because that doesn't say this is congruent to that. Don't put a check mark next to step 1 because it doesn't say this is congruent to that. Are you with me? You're only putting it next to the congruent angles or the congruent sides. All right, cross that piece of given information out. Move on. W is the midpoint of XZ. That needs to be in your proof as given. W is the midpoint of XZ. If W is the midpoint of XZ, what did that help me mark on my picture? Because I want that to follow it. Gabby? Exactly. And I like how you wrote that. What we were doing yesterday, X and Z again are corresponding. W is corresponding to itself. Do you remember the reason, Gabby? Mm-hmm. There's no midpoint theorem. Spoiler, definition of a midpoint. Okay? Now maybe in another color, I'll choose orange. That's not a congruent angle. That's a congruent pair of sides. Your first one. That is not a congruent pair of angles. That's one of your sides. Okay, my last piece of given information says that XY is congruent to, segment XY is congruent to segment ZY, and that's given. And that was straight up, you could mark that on your picture as congruent sides. There's nothing you need to pull from it. That is your second pair of congruent sides. Are you with me? And now you're done with your given information. So remember, there was a couple things that we were missing that we could assume. Right now, you only have 2 pair of congruent angles and 2 pair of congruent sides. So what do you want to say next? You could do one of 2 things. Sydney?
Did you say segment WY is congruent to segment YW?
Okay, so I'm going to go back to this name. If you say YW,
Oh, you have to say YW again. Okay.
this is the confusing part. And I told you when we were doing the hinge theorem, I said I didn't care because you didn't know about corresponding parts, but now you do.
Okay.
So I'm going to be specific about it. Okay? So back in your name, like we said yesterday, always tells you what parts are congruent. Are corresponding. So if you say YW, you got to say YW. All right? What was your reason there, Sydney? You got it. Good job. Okay, there you go. That's your third side. You're good on your congruent pairs of sides. What was the last thing that we talked about? What's the only other thing that's missing? Yeah?
Is it angle X and angle Z?
Yeah.
Third angle theorem?
Yes. And Caroline, You're allowed to name them as angle X and angle Z with one letter because there's only one angle at those. You could name them with 3 letters, like YXW and YZW. Make your life easier, though. Okay? And you're right by the third angles theorem. Angle X is congruent to angle Z by the third angles theorem. So guess what? That's your third pair of angles. Take a look at your checklist. You now have 1, 2, 3 pairs of congruent angles, steps 2, 4, and 9, and 3 pairs of congruent sides, 6 through 8. So, make your conclusion. Triangle. Go back to your proof statement. XYW is congruent to triangle ZYW. What's the reason? Yeah, Gabby? There you go. What does it mean for triangles to be congruent? That they have 3 congruent pairs of angles and 3 congruent pairs of sides. That's what you wrote in your proof. After today, you're never going to use this again. You're going to have shortcuts. And you're only going to have half of this. Okay? So theorems like side, side, side. Guess what you need? 3 sides. No angles. Okay? Side, angle, side. Guess what you need? Two sides and 1 angle. All right? It's going to get easier. Thoughts or questions on this? This was a lot. Okay. Now, with the next one, there's not that much given information, but there are new things we can assume, okay? And from that given information, we know a lot, okay? So can we talk about our first piece of given information? I tell you that segment AD, right here, and segment BE bisect each other. I just want you to listen as I talk through this with you. If these 2 segments bisect each other, what does that mean? What does that help you mark, Kyla?
Angles BCA and DCE are congruent because of interior angles.
Okay, so you're talking about these 2 angles right here?
Yeah.
Okay, those are congruent, but that's not from this information. Can we come back to that? If I tell you that 2 segments bisect each other, what does that help you mark on your picture, Taylor? Okay. Yeah. So look up here. If this segment is bisecting AD, that means this part of AD is congruent to that part of AD, right? Mark it. You already have 1 tick mark used. We haven't gotten to that given information yet. So use 2 just to distinguish. But guess what? They bisect each other, right? So what else can I mark? Not only does BE bisect AD, but you can kind of flip it too.
Can you also mark CE and then CB or BC?
Yeah. So that 1 piece of given information gives you 2 pair of congruent sides. Are you with me? Yeah? Okay. Now, the good thing is, the next piece of given information, that's already marked for us. That's this pair of congruent sides. You already have 3 pair of congruent sides right off the bat. Are you with me? Okay. The last piece of given information is that angle I is congruent to angle D. Just by the I give that to you. Okay? Now, what are we missing? Here.
From the vertical angles theorem, you can do the BCA
Okay.
is congruent to DCE, but then also since they're congruent, like it works that B is congruent to A. Or,
By the E.
Yes.
By the...
Wait. thought, like, since
We used it
vertical
before.
angles are-
That's vertical angles. So Kyla, you were trying to say that these were alternate interior angles, but really they're vertical angles. Vertical angles theorem. That is something you can always assume. Okay? That's never going to be given to you. You can assume that. So it's good looking out for that. We just had the wrong theorem with it. Okay? We will use the alternate interior angle theorem in just a second though. Okay? So there's your pair of vertical angles that are congruent. But why was I able to mark angle B and angle E congruent? Yeah?
Because the third triangle theorem and because of alternate interior.
Okay, I like the first answer, the third angles theorem, right? Because we already had two pairs of angles marked congruent. Okay? We are only, listen to me, we are only allowed to use alternate interior angles theorem when you know what? When you have,
Two lines that are parallel.
exactly. Do you know that here? Nowhere. So I like that you guys are thinking about it. We'll use it eventually, but not here. Okay? They are alternate interior angles, but I don't know that they're congruent because I don't know parallel lines. Make sense? Congruent, not parallel. Okay? So we're done. Write the proof. Okay? Now, with this first piece of given information, you marked two pair of congruent segments, and I would put those in the same box because you're using the same reason. Okay? So this was given to you, but then it helped you mark that AC was congruent to DC and that BC was congruent to EC. Now, if you're like, well, why did you name them that way? Go back to the name in your proof statement, your congruence statement. If I say segment AC, then I gotta say DC. If I say segment BC, then I gotta say EC. What's the reason? When you see bisects, there's not a theorem with that. Addie? Good. And thank you for not saying angle bisector. It's a segment bisector. What did it help you mark? It helped you mark congruent segments. That's the definition of a segment bisector. Now, technically, you could split those up into two steps. The reason would be the same, and you're probably going to want to you're going to have to add an extra box for yourself. Not wrong, okay? But when we see something like that, those two pairs of congruent sides were marked from the same piece of given information. I put it in the same box. Okay? Now, if you're doing your check marks again, which one? These were two, check. Two pairs of congruent sides, right? And we're done with our first piece of given information. Go back and use the second piece of given information. And mark that as your third pair of congruent sides. We knew that like right off the bat. And then we can finish our given information. And there's your first pair of congruent angles. But then we were kind of stuck. And we were like, there's no more given information, but I'm still missing two pairs of congruent angles. So then what did we talk about? What came next? Which pair of angles, which pair of the other two came next? Can you use the third angles theorem before you have two pair of congruent angles? No. The third angles theorem, I am going to be particular about that. I told you there's a bunch of different ways we could write this. The order could be different than mine, but the third angles theorem does not work until you've talked about two pair of congruent angles. Just what were you going to say? Yeah. And guess what? With vertical angles, we always have to use three letters. So if you name those, you could call that like angle BCA. B is corresponding with E, C is corresponding with C, and D is corresponding with A. And that's not a definition. The theorem. The theorem is what tells us they're congruent. That's my second pair of angles. And then I can talk about my third pair of angles. Angle B is congruent to angle E by the third angles theorem. There's your third pair of congruent angles. So then you write your proof statement. Triangle ABC is congruent to triangle DEC. Reason? Triangles, yeah. Definition of congruent triangles. Awesome. How are you feeling? Overwhelmed? It's a lot. Okay. I'll go back to that. I'm sorry. I do want to show you that at the bottom of the classwork, at the bottom of the classwork in class information, I did post this PDF document that has all the theorems and postulates plus some that we've talked about this year. So if you take a look, we've used the angle addition postulate and the segment addition postulate in proofs before, but you may use things, here you go. The right angle congruence theorem says all right angles are congruent. The vertical angles theorem says all vertical angles are congruent. So if you're like, okay, she used something and I have no idea what that means, you can go back here. Okay? You may have to do some searching. They're out of order because, look, here's the things we're going to use next. We did use a third angles theorem already. But here's the things we're going to use next. And those are in chapter 4. Remember, I was moving things around. Okay? But there's those things. All right. I don't think there's really anything else. But there is a lot of good information in there if you need to look at that. Just know it's there. Okay? All right. Stick with me on this. This one's a long one, and this picture is confusing. Okay? So the bars that give structural support to a roller coaster form triangles. Since the angle measures and the lengths of the corresponding sides are the same, the triangles are congruent. Okay? Now, how many triangles do you see in this picture? More than 2? But guess what? I'm only asking you to prove this. So this is confusing. There's some on your homework that are kind of like this. I would redraw these triangles. Okay? Which triangles are you trying to prove are congruent? This one and this one. Look, J, K, N. So this one and then L, M, N. So if you want to like trace over those, I don't know, like and then move them. It doesn't have to be perfect, but if you move them and put the labels on them, I promise you it's going to be much easier. Kind of see what I did there? So let's start with our given information. MK bisects segment JL. It's written in a little bit of a different way than the last one was. What does that help you mark? Segment MK, right here, bisects segment JL. That only helps you mark one pair of congruent sides. What would the congruent sides be if MK is bisecting this segment? What's that help you mark?
K and then in it.
What?
Maybe K and then in it.
So if this segment is bisecting this one, I'm looking at this one right here being two congruent parts. Guess what? The next part is going to be what you just told me. Right? Okay, so here's what I want you to mark. If MK is bisecting JL, that means this part and that part of JL are congruent. Now I've moved on, and the next part says that segment JL bisects MK. So Sydney, NM and NK are also congruent. When it's written as two separate parts, mark them separately. Okay? We know what that reason is going to be, the definition of a segment bisector again. Okay? You also know that JK is congruent to LM. That's part of the given information. Now, there's three congruent pairs of sides. But then I move on and I tell you JK is parallel to LM. Remember that the markings for parallel are different. They're like the tops of an arrow. Remember that? What does that help you mark? You don't have any angles yet. Do you know?
Can't use the corresponding. They're not, it's like interior.
So I want you to highlight your parallel lines. And I then want you to highlight JL. That's your transversal, one of them. Remember that the alternate, we're looking for alternate interior angles here. The alternate interior angles are created by the parallel line and the transversal. So guess what? This angle at J is congruent to parallel line transversal, this angle at K. Are you with me? Do you see that these angles are going to be congruent right here? Parallel line, transversal, parallel line. These angles are congruent. Okay? Now, I'm going to erase my highlighting for the transversal, and I'm going to change it. Because guess what? This, hang on, highlighter, blue. This is also a transversal. So what other pair of alternate interior angles would be congruent? Not angle J and angle L now, but Tessa? There you go. Okay. Where's your third pair of angles that are congruent? There's actually two answers for this one. Noel?
Angle J and K.
Okay.
And M and L.
Reason?
Third angle theorem and their vertical.
Okay. You could do both. I don't care. All right. And if you did the vertical angles theorem, it could go at the top of your proof. But if you did third angles theorem, it has to go towards the bottom. Okay? Now, I know we only have 2 minutes left. of class. So I'm going to get as much of this written as I can. And I can finish it and post it for you to check your answers on Google Classroom. Now, I'm going to put the first 2 pieces of given information. I didn't do this before. But because we use the same definition of segment bisectors, I'm going to put it in the same box. Are you with me? So that helped me mark that segment JN was congruent to segment LN, and segment MN was congruent to segment KN. And the reason there was the definition of segment bisectors. No theorems with segment bisectors or midpoint. All right, there you go. There's 2 pair of congruent sides. The third pair came from my given information. Segment JK and segment LM, and that was just given to us. But that's my third pair of given sides. So you're done with the sides after step 3. Sorry if you can't see that. Now remember, the check marks go next to what is congruent. Parallel does not mean congruent. So when I write that segment JK is parallel to segment LM, that doesn't get a check mark, right? That is going to help me mark congruent angles, but that doesn't tell me the congruent angles at this step. That's what goes after them. Okay, and remember that those angles are going to be by the alternate interior angles theorem. So I want you to try to finish this. Alternate interior angles theorem, third angles theorem or vertical angles, and then just definition of congruent triangles. Okay, I'll go over this at the beginning of class tomorrow, but I want you to do the homework, okay? And I'll answer questions at the start of class tomorrow. Do your best without looking at the answer key. Okay? Do your best without looking at the answer key. Even if you only get like 2 sides and 2 angles in your proof before you have to go, I'm proud of that. That's good. All right? Do your best. We do have Panda Prime Time today if you'd like to stop by and go over anything. Okay? I'll post this on Google Classroom if you'd like to look at it. Great job. See you tomorrow.